All right, so now that we've been able to define what antiderivative is, we looked at indefinite integrals. So to be able to perform antiderivative of more complicated functions, we look at a formal definition of antiderivatives and their properties. Now recall that we use this notation f prime of x or df over dx under derivative to represent the derivative of function f, all right, and f of x plus c to represent antiderivative of f. Now, a more general definition or representation of antiderivative of f of x is given by f of x plus c is equal to integral of f of x dx. Now, this sign here is known as, or this symbol here is called the integral sign, and integral of f of x dx is called the indefinite integral of f of x. Right? Indefinite means that it has no limit point. It has no starting point. It has no ending point. Right? So it's called indefinite integral of f of x. So given any function f, the indefinite integral of f is denoted by integral of f of x dx, and is the most general antiderivative of f. If capital F is an antiderivative of f, then integral of f of x dx is given by capital F of x plus c. The expression f of x is called the integrand, and the independent variable x is called the variable of integration. And the act of finding the antiderivative of f of x is referred to as integrating f. Now the function f and an antiderivative function small f and an antiderivative big F with the functions f of x plus c is often referred to as family of antiderivatives of f, of small f. So for example, we looked at the function f of x, which is equal to 3x squared. Since f of x plus c, which was equal to x cubed plus c, all right, is the antiderivative of f of x, it implies that f of x plus c, which is x cubed plus c, is equal to the integral of f of x dx, which is equal to the integral of 3x squared dx. So this means that integral of 3x squared dx is equal to x cubed plus c. Now the collection of all functions of the form x cubed plus c is known as the family of antiderivatives of 3x squared. So for example, we have x cubed plus 2, x cubed plus 1, x cubed minus 1, x cubed minus 2, x cubed minus 3, and so on. This is what is known as the family of antiderivative of the function f of x is equal to 3x squared. All right, so for some function, if I have f of x is equal to x to the power n, where n is not equal to -1, then the integral of x to the power n dx, this is equal to x to the power n plus 1 divided by n plus 1 plus c, because this here is known as the antiderivative of f of x. And this comes directly from differentiation, right? If I have a function x to the power n plus 1 divided by n plus 1, since n is a number, this is going to be 1 over n plus 1. Then we differentiate x to the power n plus 1. If I differentiate x to the power n plus 1, you multiply the exponent by the function. So I have n plus 1 times x. You subtract 1 from the power. So we have n plus 1 minus 1. And this is equal to n plus 1 divided by n plus 1 all to the power x to the power times x to the power n. And this is equal to x to the power n. All right, so if I have a function given by x to the power n, then the integral of x to the power n dx, this is equal to 1 over n plus 1 x to the power n plus 1. All right, and that is known as the power rule of integrals, as long as n is not equal to -1. All right, so let's look at how we can evaluate some integrals, some indefinite integrals. The first one we're looking at is if we want to integrate 4x cubed plus 5x squared minus 2x plus 3 dx. All right, here we can apply the sum and the difference rule. That is to say that the integral of the sum or the difference of functions is the same as the sum or the difference of the integrals. All right, so this is the same as integral of 4x cubed plus dx plus integral of 5x squared dx minus integral of 2x dx plus integral of 3 dx. Okay, so this is equal to, if I'm to integrate, so we add 1 to the power, that will be 4, and divide it by the function. So I have 4 divided by 4, x to the power 4, plus, we now add 1 to the exponent, that will be 3, and divided by the function. So I have 5 over 3 x to the power 3, minus, I add 1 to the power, 1 plus 1, that will be 2, so I have 2 divided by 2 x to the power 2, plus 3 is the same as 3x to the power 0. So if I add 1 to the power 0, I'll get 1. So this is 3 over 1 x to the power 1. Then plus our c. So if we simplify this, we have x to the power 4 plus 5 over 3x cubed minus x squared plus 3x plus c. Let's look at another example. If we have integral of x squared plus 2 times square root of x divided by x dx, we can simplify this to give us integral of x squared over x dx plus integral of 2 root x over x dx. If we simplify this, we'll get integral of x dx plus, you can put the 2 out, to integral of x to the power minus 1 over 2. And this is equal to 1 over 2x squared, all right, plus, we add 1 to this, minus half plus 1, that will be a half. So we have 2. We divide this by the half. Then we have x to the power 1 over 2 plus c. Okay, so this is equal to x squared. Then we have plus, this will be 4 x to the power 1 over 2 plus c. All right, let's look at the third one. You have integral of 3 divided by square root of 1 minus x squared dx. Okay, then this is equal to, we can put a 3 out, integral of 1 over square root of 1 minus x squared dx. Now this function here is, the integral of this function here gives us the sine inverse of x. If we look at the chart that was given earlier on, so we have 3 sine inverse of x plus our constant c. Okay, let's get another example. If you want to find the integral of cos of x times tan of x dx, this is equal to integral of cos of x. Tan x is the same as sine x divided by cos of x. We have dx. This is equal to integral of sine x dx. Right, if we integrate sine x, we get minus cos of x plus c.